Hello students, we have already done types of matrices and we have also learned how to add and subtract matrices. Today I will take up multiplication of matrices. We say that a matrix A is conformable to another matrix B for multiplication, that is AB exists only when number of columns of A equals number of rows of B. That is, if A is an m by n matrix and B an n by p matrix, then the product AB will exist and it will be of the order m by p. Here you can clearly see that A is an m by n matrix. That means there are m rows and n columns. Matrix B is a n by p matrix, which means n rows and p columns. So number of columns of A is n and number of rows of B is n, which are equal. Hence we will be getting the product AB. Product AB will exist. Now we will learn how to multiply matrices. What is the product of two matrices? I have taken a matrix A of the order 2 by 3 whose elements are A11, A12, A13 and A21, A22, A23. Similarly, I have taken another matrix B of the order 3 by 2 whose elements are shown here. Now I will be multiplying both the matrices. I will be getting the value of AB. But first let me quickly check whether product AB will exist or not. Number of columns of A is 3 and number of rows here is in B matrix B is 3. So definitely AB will exist and the product of the matrix will be a 2 by 2 matrix. Now we will learn how to multiply them. Since AB will be a 2 by 2 matrix, so we will have 2 rows and 2 columns. Now what will be the element of the first row, first column? So to find out the element, to list the elements here, to get the first row, first column, we will look at the first row of the matrix A and the first column of matrix B. We will multiply A11 with B11, A12 with B21 and A13 with B31 and we will add them. By doing so, we get the first element of our product matrix. Similarly, for the second element, that is first row and second column, we will take the first row of matrix A and we will look at the second column of matrix B. So the element will be A11 into B12 plus A12 into B22 plus A13 into A13 into B32. So we get the second element. Now we will list down the element belonging to second row first column. So second row first column means the second row of the matrix A will be taken and the first column of matrix B will be taken. So A21 into B11 plus A22 into B21 plus A23 into B31 gives us the element here. And for the second row, second column, we will multiply the elements from second row of matrix A with the elements in the second column of matrix B. That means A21 into B12 plus A22 into B22 plus A23 into B32. So we get the product of the matrices A and B here, which is a 2 by 2 matrix. Let's now move on to the properties of multiplication. The first property states that multiplication of matrices is not commutative in general. If AB exists, it is quite possible that BA may not exist. If we have a matrix A which is a 3 by 2 matrix and a matrix B which is a 2 by 2 matrix, then definitely AB will exist because we have the number of rows of B which is equal to number of columns of A. Hence we will get a 3 by 2 matrix. But BA will not be possible. Why? Because number of columns of B is 2 and number of rows of A is 3 and they are not equal. So BA will not exist. Further, if AB and BA both exist, then it is quite possible that AB is not equal to BA. Now, the above discussion, however, does not imply that AB is never equal to BA. We can have matrices A and B such that AB is equal to BA. And in such case, if AB is equal to BA, we say that A and B commute. And if AB is equal to negative of BA, we say that A and B anti-commute. We'll move to the next law, associative law. If A, B and C are three matrices, then the product of A and B multiplied with the matrix C is equal to A multiplied with the product of matrices B and C whenever both sides of the equality are defined. What does distributive law state? If A, B and C are three matrices, then A multiplied with the sum of the matrices B and C is equal to matrix A multiplied with matrix B plus matrix A multiplied with matrix C. And sum of the matrices A and B multiplied with matrix C is equal to AC plus BC whenever both sides of the equality are defined. Now we have existence of a multiplicative identity. For every square matrix A, there exists an identity matrix of the same order such that A into I is equal to I into A, which is equal to the matrix itself. Now we all know what an identity matrix is. It is a square matrix whose diagonal elements are 1. Now as far as associative law and distributive law is concerned, you all can prove this by taking suitable examples. The next property. Product of two non-zero matrices can be a zero matrix. This is explained with the help of an example. Matrix A and matrix B both are taken to be a 2 by 2 matrix. The elements of matrix A 0, 1, 0, 2 and elements of matrix B 1, 2, 0, 0. Now since they both are 2 by 2 matrix, number of columns of A is equal to number of rows of B. So definitely AB will exist. Now let us find out what AB will be. That means we will multiply both these matrices. We have just learned how to multiply and how to get the elements. So we go ahead with the same method. 0 into 1 plus 1 into 0. 0 plus 0. 0 into 2 plus 1 into 0. 0. And similarly the other two elements of the product matrix is also 0. So we get a null matrix 0, 0, 0, 0, a 2 by 2 matrix. What do we mean by positive integral powers of a square matrix? If A is a n-rowed square matrix, then we define A square as the product of matrix A with itself. That means A multiplied with A. A cube is the product of A square and A. That means A into A into A. A is multiplied 3 times. So in general we can say that A to the power n is equal to A into A into A, and we multiply it n number of times. Now there are few theorems based on positive integral powers of a square matrix. The first theorem states that if A and B are square matrices of the same order, then A plus B whole square on expansion gives A square plus AB plus BA plus B square. And when we have AB is equal to BA, then this expansion becomes A square plus 2AB plus B square. The second theorem, the product of the sum of the matrices and the difference of the matrices on expansion gives A square minus AB plus BA minus B square when AB is not equal to BA. But if we have cases where AB is equal to BA, then A plus B into A minus B is equal to A square minus B square. Next, what is a transpose of a matrix? If A is an m by n matrix, then the matrix of the order n by m, which is obtained by interchanging the rows and columns of A is called the transpose of the matrix A and is denoted by the letter A dash, the symbol A dash or A to the power T. Now there are some results on transpose of a matrix. For any matrix A, the transpose of a matrix is equal to A. A dash whole dash is equal to A. If A is any matrix and K is any scalar, then Ka whole dash is equal to Ka dash. For any matrices A and B of suitable orders, A plus B whole dash is equal to A dash plus B dash and AB whole dash is equal to B dash A dash. So children, that is it for today. I'm sure that side by side you people are solving questions based on the concept that is being taught. Stay at home, stay safe. Thank you.